This morning we're joined by lead solutions engineer Martin Weiss. He's from Jembi. Good morning, Martin.
Good morning, Professor Boyce.
Okay, you can call me Professor. So Martin, it's really great to speak to you this morning, and I know that you've got a wealth of experience and stuff that you can share. So I'll try to tap into the core of that. Just before we start, I have to admit I have a Chewbacca onesie, and I know that will make you happy.
Yes, I'm thrilled. I don't think it wasn't a career choice to do engineering. I think it started like at the age of 4 or 5, where I actually got a Meccano set, if you remember the old Meccano set. Yes. Sorry, from my grandfather. And I played with the Meccano, and I saw that you can build things. But following that, if I remember the history correctly, I got this old 8mm projector, an old mechanical projector. Which wasn't working, and I took the thing apart. It was also like the age of 5 or 6 or so. Took the thing apart and I actually fixed it and made it work. It didn't last for very long because I think I opened it again and took it apart, and it eventually turned into a pencil sharpener, I think. I saw then that I think that kind of sparked my interest in things and how things work, and I think it just went from there to looking at other things in the same kind of way. So I don't kind of really see engineering as a career. It became a hobby. Electronics, I think, was the kind of next thing, and how you put things together. I got involved in photography. I was really interested in photography, both from the artistic side, but also from the technical side. How does film work? I built my own darkroom in the good old days, and building, some of the technologies that you need in there. It was not radical. It's like a timer to switch a light on and off, a temperature sensor, a little vibrator, those kind of things. So I got involved in building these things, not because it was my passion, but because I was trying to solve some other bigger problem, like develop forms.
So just remind me again, what's that Afrikaans word you always say that you had to learn at university?
You're talking about one of those really good tools that I keep in my toolbox. It's called the Eerste Orde Homogene Lineaire Differentiaalvergelijking.
I'm pretty sure many of our Afrikaans students won't be able to say that. Yes.
Yeah.
Could you tell me, Martin, something that I think is really up your alley is to understand where things are moving towards. So we often get the question from students, or at least from entrants, what are the job opportunities and what should they be focusing on if they want to ensure that they get a job? So I think engineers get jobs. I think it just takes a matter of months or so. But the question is, what do you think is the low-hanging fruit in the next 5 to 10 years? Where do you think things are progressing towards?
I mean, if you look at the trends, it's data analytics, big data, machine learning, and AI. But this also might be a hype where it just becomes another tool it's. But certainly now, today, if you're an analyst and you've got some kind of maths background, you understand Fourier, and you can do Eerste Orde Homogene. Like you can certainly move into, I think, anything, into law, into finance, into medicine, into any avenue. I think engineering is a good background for any of those. We have tools that those other what are they called, facilities don't particularly have. I think engineers should use engineering as a tool, it's not a career, it's a tool. It's a tool to solve. So you use the stuff that you've learned. You can apply Fourier to other things that in business.
Yes.
For example, there's all kinds of these.
Yeah, even truth tables. I have found myself using truth tables, which those binary simplification maps. I forgot the name. Kano maps. I've used Kano maps, completely removed from engineering. Could you maybe just also, we spoke earlier about data just before I started recording. How important do you see in the whole movement towards big data? How important do you see data acquisition being? Because we spoke about the difficulty of getting access to this big data, and everybody's raving about big data. But I've heard some people say that one of the challenges is just generating that data. Do you think there's an opportunity for electronic engineers there as well, and electrical engineers?
Absolutely. I think this whole connected world, which kind of started, I don't know, in the 60s, it was connected, but it was connected with wire, now moving to wireless, is going to provide all kinds of opportunities where things are connected just because of the nature of it. I mean, here's a little, like a little Arduino like this, which has got a screen, it's got a processor, it's got Wi-Fi and Bluetooth, and it's low power, and it charges a battery, and it costs $50. You can build, the world is yours, so you can build a tracking device, you can build a monitoring device for anything, and it can get connected. So I don't think the technology is the challenge anymore. I think that the challenge is, how do you turn that into money? How do you make a career out of this? So, monitoring manhole covers or pinball machines is relatively simple. The technology is advancing. You know about LoRaWAN and IoT, narrowband, and all those technologies. I mean, those are, and even peer-to-peer kind of mesh networks. So that technology is there. It's available for us to use and to build solutions for things. The trick is finding the right things. But it's not always, I think, necessary to use the most bestest and highest technology. I have these things, which you might recognize. Let me just find one. So this is it's a NFC card that we use for tracking immunization in African countries, for example. And we write the whole immunization history on this card. It hasn't been used in this kind of setting ever. When I presented this to them, they said, "Oh, this, how can you write to a piece of plastic? This will never work." So we sat down, and I got two engineers, and we built a demo of this thing, which worked on a phone, and I tapped on the phone. When we showed these people, they were gobsmacked that you could actually write to a piece of plastic and move it around.
Yes.
It doesn't have to be radical technology that changes, that can make big impact, and that can have opportunities. So I think it's making the most appropriate decision and mitigating the risk. If you can solve that problem, I think you can do that in anything. If you're going into finance, or if you're going into law, or if you're going into agriculture, teaching, medicine, those tools that you learn as an engineer, I think that's kind of what helps you. We problem solvers. We mitigate risk and we problem solve.
So it sounds like, if I can put words in your mouth, if I asked you what is the biggest skill that university students lack, it sounds like what you're saying is to just focus on problems rather than solutions, so that they can solve the right problem, and then also to solve it in such a way that there's a business case behind it, and to ensure that there's some sustainable monetary drive behind it, right? That's a big lacking factor, I think.
I think so. And I think, through your technology transfer offices, there's that kind of move towards that. But I think it's that.
But it's still solution driven. Even in the university that we're getting right, it's still solution driven. I think the focus should be on the problem. Let's focus on just solving problems rather than thinking up solutions that solve hypothetical problems. I don't think that works well.
No. Well, if you have one tool, if you have a hammer, everything looks like a nail. So
yes.
Whereas if you've got a suite of tools, you can solve really big, complex problems. But you're absolutely right. I think the gap is trying to define what the problem is, not what the solution is. The solution is obvious most of the cases once you know what the actual problem is.
Yes, and if you have the technological toolbox, it's exactly what you're saying. Okay. So
to data, the opportunities for data is understanding problems, I think, is being able to analyze data. So in those kind of environments, or just sitting and listening and thinking. One of the things I learned I did this master's in biomedical engineering. One of the big things I learned is that engineers and doctors do not speak the same language. We cannot communicate to each other without an interpreter. And it's really important that these interpreters understand what doctors are saying and translate what doctors are saying to engineers. And that helps engineers solve the problem. Because otherwise we go off on a tangent and we solve things that we think the doctors want, and we give them technology which doesn't work.
Just on that topic, you're married to a doctor?
Yes.
Okay, cool.
It was the intent was to get access to drugs, but that never worked.
I'll quote you on that. Thank you very much for spending time with me and sharing your insight and your story with me. And all the best with the rest of your illustrious career.
My pleasure. Thank you, and to you too.